Okay, 8-5, day 4. Nothing new here. We're going to do a couple revolving around the non-X and Y axis and then set up a couple of trickier problems with you. So we're going to jump right into example 1. We are going to take x equals y squared plus 4. The part of this graph that's in quadrant 1. And revolve it around the vertical line. X equals 5. Okay, so remember, this is a sideways parabola. I gave you a formula to get the vertex for it. It is, to get the y value, take the opposite of the b, which there is no b, so that's going to be 0. Divide by 2a, still 0. So plugging in 0 for the y, you get x equals 4. So in graphing this, and I only want the part that's bounded in quadrant 1. I know that the vertex is at 4, 0. And then it opens, I'm going to make this negative, because that's the only way it's going to be bounded. I want it to open this way. And I could draw the other half, but I don't need it. I only want the part in quadrant 1. And we're going to revolve around the vertical line, x equals 5. So that's going to be 1 here. So we're going to revolve around this. So when you see your line, you treat it like it's a y-axis. It's parallel to the y-axis. So I want my rectangles to go like this. But remember, my reference is over here. So I do see a gap. So it's definitely a washer. R1 and R2. 9 times out of 10, it was always right minus left. But when I'm standing over here, R1 has to be your bigger radius, because when we do a washer, we're taking the outside cylinder and subtracting the inside cylinder. So R1 is the distance from here, my axis, all the way to the far end of my rectangles. Well, you can see that's going to be a constant of 5 all the way through there. I'm going from 5 back to 0. So R1 is 5. Now here's the tricky part. What is R2? I need an expression that gives me the distance from my dotted line to the ends of each of these rectangles, and it changes as I move through my region. So I need an expression that gives me this distance. Okay. Well, think about what the equation gives us. When I plot the point, I go over and up, over and up. So what this horizontal distance, the equation, I'll grab purple, I guess. The equation, this part is my equation. This is a distance of 5, and I want the part that's past the equation. So I have to do a subtraction. I got to take my distance of 5 and subtract the function value. So we'll take the axis we're going around, which is 5, and subtract the equation, which is a negative y squared plus 4. So notice I put parentheses there because I had to subtract both parts of this. Okay, as a general rule of thumb, if your axis of rotation is to the right of your region, you will be subtracting to get your radius. You're going to see when we're to the left of it, it'll be adding. So keep that as a general rule of thumb. If I'm standing to the right of it, subtract. You see when we stand to the left, you're going to be adding. So I can simplify this first before we get going. It'll be 5 plus y squared minus 4, which is 1 plus y squared. So now I'm all set with my R1 and R2. Oh, I just need my y boundaries. So I've got 0, and I need to know where this crosses. What I know about this point is that the x value is 0. So if I subtract 4, Well, let's see, subtract 4. Divide by -1. Square root, I get positive and -2. So remember, it would have crossed at +2, and had I done the bottom part, it would have been -2. So I know I'm going from 0 to 2. Pi R1 is 5 squared. I'm doing the washer formula. Minus this one squared. dy. So I have y boundaries, y's in my equations, dy. I need to FOIL this out and distribute a negative after I FOIL. So I'll do a little bit of algebra here. So I got 25 minus FOILing. We've got 1 plus y squared is plus 2y squared. Plus a y squared times a y squared is a y to the 4th. Now I'll distribute my negative. So minus 1 minus 2y squared minus y to the 4th. So that'll become 24 minus 2y squared minus y to the 4th. All that times pi. And I still have not done my antiderivative yet, but I'm ready. So pi, that'll become 24y. That'll become a 3 1/3, so 2/3 y cubed. A 5 1/5. And then it's calculator work. Let's see. Oh, I think I have it in already. Pi 24x minus 2/3 x cubed minus 0.2 x to the 5th. I did. So 2 is 147.45 minus the 0 is 0. Okay. The second one, we're not going to do the algebra because you're going to see it's pretty much identical. It's the setup and finding the radius, the 2 radius lengths out of the challenge. So we're going to use the exact same equation, still quadrant 1, but this time we're going to revolve around x equals -2. So we're just going to set it up. We're not going to bother with that the calc part because I think it's pretty simple. So x equals -y squared plus 4 in quadrant 1. And we're going to revolve around x equals -2. So I know what the graph looks like. 1, 2, 3, 4. Crosses at 2. 1, 2. Make it bigger. So that's 2. That's 4. And we are going to revolve around x equals -2. So my axis of revolution is over there. Again, that is parallel to the y-axis, so I treat it like a y-axis. And I draw in my rectangle perpendicular to it. I do see a gap. So that's washer. And now it's your R1, R2. So you stand on your axis. R1 has to go all the way to the far end of your rectangle. So I need something that tells me this distance, and you can see that changes. So it is determined by the equation. So remember, the equation just gives us my from the origin over and up. So the over part is my x value, and that's determined by the function. So the part from the y-axis over is the function, but I still have this extra distance here. So I have to add 2 and then the function. So R1 is the function plus this distance of 2. It doesn't matter which one comes first. So, like I was saying at number 1, if your axis is to the right of your equation, your radius is going to involve subtraction. If it's to the left, it's going to be adding. Adding, it doesn't matter which one comes first. So simplifying that, that'll be a negative y squared plus 6. R2 is the shorter distance from your axis to the close end of the rectangle. And you can see that's a constant value of 2 all the way through there. So that will be 2. And to get the volume now, we're just going to set it up and leave it. We're going to be going 0 to 2. Pi. R1 is this quantity. So negative y squared plus 6, or 6 minus y squared, and you have to square it, minus R2 squared dy. So the algebra is in calculus is very much like number 1, so I'm not going to take the time to do that. But I did want you to have an example where the axis was on a vertical and on each side of the region. Okay, now for some tricky problems that you're going to try. So we're going to set them up, and you're going to finish them in your notes or homework. These are going to be homework problems, so I guess I don't care where you finish them. The first one is number 19. And if you look at 19, grab the book. This time we're not really rotating. You've got a region here. Region R under the graph. So they give us a curve. Y equals x to the 0.6. We're going from 0 to 4. Forms the backside of a solid. The cross section. So if you were to slice this, you're going to get these right triangle regions. So it's not like it's a part of a cylinder here. It's got that flat surface, flat and flat. So they're all triangle regions. And we want to find the volume of that solid. And they're only going that quarter turn. So it's a 90-degree angle every time. So, getting the sketch in here. So, let's see. That is y equals x to the 0.6. Okay, so the cross sections are these triangular regions where the legs are equal. So they're isosceles triangles, isosceles right triangles. And if we think about the thickness of them, they are going to be triangular prisms. And we're going to add up all of the volumes from 0 to 4. So this stops at 4. Okay. So our pieces are triangular prisms, just like a cylinder, where the base is an isosceles triangle. So we need the area of the base times by the height. The height is your dx here. And the area of the base is just the area of a triangle. So the volume is going to be area of the base times by the height. The base is a right triangle, so it's base times height divided by 2. And then the height of them is our dx. So our base and height are determined by our equation, both of them, because they're equal. So the height is determined by this. So we're ready to substitute in x to the 0.6 here and x to the 0.6 here. So 0 to 4, base is 0.6, or x to the 0.6. The base and height are both the same, x to the 0.6. You can divide by 2 or times by a half, and then a dx. And I'll let you finish that up. Number 22. '22 is a little bit trickier. We are going to use in geometry, when we did the volume of a right circular cone, base radius r, altitude h, we just plugged and chugged into this formula, 1/3 pi r squared h. You are now going to develop this formula. All of our geometry formulas for volume came from calculus, and you're going to do this one. Kind of excited about it. So 22. So we're going to discover the volume of a cone. And we know the formula, so you'll know when you have your answer. The answer is going to be 1/3 pi r squared h. So thinking about revolving, what region we would have to revolve to get a cone shape? Well, think about it. All a cone is a triangular region revolved around an axis. And if I go around the y-axis, this distance across here is my radius. This point up here is the height of my cone. So because I know these distances, I have ordered pairs. This would be whatever r is, 0. This would be 0h for an ordered pair, because I didn't go left or right, I just went up. I can use these 2 points to write the equation of this line, and then we'll do our calculus. So the equation of a line, so I'll go there. So we need to know the slope. So the slope, I'm going to start up here, change in y, so that's h minus 0 over 0 minus r, that's the change in x. Don't be afraid of the letters. So our slope is negative h over r. My b value, where it's crossing the y-axis, it's going to cross at the height. So I can go right into y equals mx plus b. So y equals, slope is negative h over rx plus h. Okay, so now we'll do the calculus. So we've got our equation. So we want to find the volume by taking this area revolving around the y-axis. So my rectangle's going this way. We're going to use the cylinder formula because there's no gap. So for this cylinder, my radius, I need it in terms of y though. I know I'm going to be going from 0 to h. So you've got to kick this around, get it to x equals. So remember, the only real letter here is x. The rest of these are treated as constants. H and r are constants that we just treat them as numbers. So first thing I'm going to do is subtract h. Oh, y is a letter too. X and y are letters. So first subtract h. So y minus h equals, I've got a negative h over r times x. Now to get x by itself, I'm going to multiply by the reciprocal on both sides. So I'll grab another color here. So we're going to times this whole side by a negative r over h. That's going to cancel. I am going to take the time to distribute this. So we will have a negative r over h y. When I distribute here, think of that as h over 1. The h's are going to cancel. I'm going to have a plus r equals x. So our radius is the equation of this line in terms of y, which we just found. So our radius is negative r over hy plus r. And now we can plug into the volume formula. And remember, treat r, and h as constants. So you're going to do the antiderivative from 0 to h pi this radius squared dy. And remember, the only letter you have in here is the y. Treat r, h, and r as constants. Good luck. So do the antiderivative. You can FOIL it, or you can do hit it with a 1 and just do a power rule on the 2 if you want to be clever. Okay, next one is 23. 23 and 24 go hand in hand. 23 says, figure 850 shows a sphere of radius 10. So it's going out 10 in each direction here. Find the volume of the sphere by calculus. Show that the answer you got in 23A agrees with the formula you learned in geometry. So to get the volume of the sphere, well, it looks like they're going around the y-axis. So we want this half circle revolved around the y-axis. That will make a sphere. So 23. We need a half circle. I guess it didn't matter if I went around the x-axis or the y-axis, but we need the equation for this half circle. Oh, I didn't do the best job there. But if you remember the equation, the radius is 10. That equation is x squared plus y squared equals the radius squared. And if I'm going around the y-axis, I want to see y's in my equation. I can see that this is a cylinder. And I know I'm going from 10 to negative 10 or negative 10 to 10 on the y-axis. So volume, negative 10 to 10 pi. Okay, I need get this to x equals. So we are going to subtract the y squared. So x squared equals, that'll be 100 minus y squared. And then I will raise to the 1/2 power. So we've got 100 minus y squared to the 1/2 power. But then all of that has to get squared. And I'll let you finish that up. And then the last one is 24. And here it wants us to, I believe, develop the formula for the volume of a sphere. Derive the formula. So just like we did, we can do the same thing here. We'll take this half circle. But instead of having a radius of 10, we have a generic radius of r. And we're going to revolve around the y-axis. So it has a very similar equation. It's still the equation of a circle. It's x squared plus y squared equals r squared. R is being treated as a constant. So we'll do the same volume, except we're going from negative r to r. We want to get this to x equals. So just subtracting the y squared. So x squared, r squared minus y squared, and then we will raise to the 1/2 power on both sides. So we'll have pi. times our radius. And then I've got to square that according to the cylinder formula, dy. And then you finish that up. Your final answer should be the equation for the volume of a sphere, which is 4/3 pi r cubed. So hopefully you get there legally. And that's it.